Hello friends, I am Dr. Prof.Chishty and I am teaching physics to the BSc first year students. My today's topic is interference. What is interference of light? Which we studied in our previous classes, that whenever there are two sources of light, S1 and S2, light rays are coming out from these two sources. They will overlap each other and there is formation of the interference pattern. Means there is on the screen, if a screen is kept here, then there is formation of bright and dark bands are observed on the screen. So this phenomenon is called as the interference of light. So for our interference we require two sources of light, but there are certain conditions to be fulfilled for getting the interference of light, that the two sources should be coherent. Coherent means similar in all respect. Their phase difference should be same or constant phase difference, their amplitudes, intensity, everything should be same. Two sources should be monochromatic. Monochromatic means have the same wavelengths. Two sources should be narrow. Narrow means the broad sources you are not going to get the interference of light. Two sources of light should emit the light waves in the same direction, and the two sources of light should be very near to each other. If all these conditions are fulfilled, then we say that there will be interference and a steady interference pattern will be observed on the screen. What we studied in our previous classes or our previous knowledge. Now in our today's lecture we will study about the interference due to the reflected light in thin films. Interference in thin films, due to reflected light. Now let us see what will happen in the interference in the thin film due to the reflected light. So we will consider a thin film of thickness small t. Then light will be allowed to incident here. Let us consider here thin film. This is the thickness of the thin film t. The refractive index of this thin film is mu, and the light ray is allowed to incident on this thin film. Okay, S is a source of light. Now this light ray will be refracted here, and it is partially reflected, means there is partial reflection take place at this point of incident. So suppose this point is A point. Now this point is suppose B point or M point. So, okay. So now at this point also there will be the reflection of light. Light is partially reflected and partially refracted. So this light ray at this surface will also be reflected in the same medium, and there is reflection of light. Okay. So if I say that this point is a C point, and if I draw here one perpendicular as N, and this point is suppose here A point or no, C point, and I will draw a perpendicular here also, that is M. I will draw the normal here also. This angle is angle of incidence I, therefore automatically this angle become angle of incidence I. Now here this perpendicular will continue, and this angle is angle of reflection. I will extend this and I will join this, so that this point becomes E and this point becomes P. Now see, this is the construction. Now in this diagram, there is a certain path difference between these two rays. Between suppose ray T and R, there is certain path difference. So what is the path difference between these two rays? We will calculate that path difference. Then we will equate the path difference for the condition for steady for bright band as n lambda, and condition for dark band as 2n plus 1 lambda by 2. So we will see that. So first let us calculate the path difference. So to calculate the path difference, I will say that the path difference x is equal to from this point I will say that it is the point, suppose MN, or suppose it is point B. Okay? So part difference is AB plus BC. AB plus AB plus BC. This distance is travelled in a medium of refractive index mu. So I will multiply it by mu minus this distance, minus AN. Means this first ray, this ray has travelled additional distance AB plus BC into mu, because this distance is travelled in medium and this distance is travelled in air. From the point N and C, both are travelling the same distance. So it is called as a path difference. So I will find the value of AN here. To find the value of AN, I will use the formula refractive index is equal to sin I by sin R, Snell's law. Okay, and sin I in this triangle A and C, this angle is 90 degree, this angle is I. So I say that AN upon AC is sin I. AN upon AC is sin I. And if this angle is I, this angle is R, this is 90 degree. So I will find here the sin R in this triangle AMC, sin R. Sin R here is opposite, CM upon AC. CM upon AC. This is the CM upon AC. So AC get cancelled and you will get the refractive index mu is equal to AN upon CM. Okay. Now I will write here that for AN I will write AN is equal to mu CM. So this distance x will be equal to mu AB plus BC as it is, mu AB plus BC as it is, minus for AN I will write mu CM. Okay. Now mu is common, mu is taken common. Okay. If mu is common, then AB plus BC minus CM. AB plus BC minus CM. Where is AB plus BC minus CM? So here you will get here AB plus BC. AB plus BC. This distance plus this distance should be equal to PC distance. Because this distance is equal to this distance. Okay. So I will write here x is equal to mu into PC minus CM. Okay. So now I will find what is PC minus CM. PC, this distance PC minus CM. Okay, minus CM, this distance will be equal to PM. So x will be equal to mu PM. X will be equal to mu PM. This is the part difference in terms of PM, this length. Now my aim is to find this distance PM. So I will use here the formula. This angle is also R, this angle is also R, and this angle is 90 degree. So in triangle AMP, I will write here cos R. Cos R is equal to adjacent upon hypotenuse. This is the adjacent side. PM upon AP. PM upon AP. This is the value of cos R. So here PM will be equal to AP cos R. AP cos R. Now what is AP? This distance. It is the thickness of the film T up to AE. AE plus EP. AP means AE plus EP into cos R. This AE is also T. It is also T. that is 2t cos r. This is the path difference. This is the path difference. Sorry, it is the value of Pm. It is the value of Pm. So I will write here the value of Pm in this equation. Therefore, x is equal to mu into 2t, or I can write it 2 mu t cos r. This is the formula for the path difference in the two rays which are reflected by the thin films in the same medium. Now, if this path difference is equal to n lambda for bright band, we know the condition for the bright band. For condition for bright band, if suppose here path difference is equal to n lambda, so I will say that 2 mu t cos r, if it is equal to n lambda, then the point will be bright. But here in this path difference, one thing should be noted, that this path difference is calculated using the geometry of the figure. But according to the electromagnetic theory, when there is the reflection from the thin films, then there is a phase difference between the two refracted rays, and there should be phase difference of pi degree or lambda by 2 radian. So that much path difference should be subtracted from the actual path difference. So I can say that here 2 mu t cos r, I will write here 2 mu t cos r minus lambda by 2 should be equal to n lambda. So this corrected path difference I will write here, corrected path difference according to the electromagnetic theory, then x is equal to 2 mu t cos r minus lambda by 2. So this lambda by 2 will go to that side. 2 mu t cos r should be equal to n lambda plus lambda by 2. I will take the LCM and take the lambda common. 2n plus 1 lambda by 2 is 2 mu t cos r. This is the path difference. Sorry, this is the equation for the dark band, for the bright band. If suppose here the point is dark, if suppose here for the point to be dark point, condition is that path difference should be equal to 2n plus 1 lambda by 2, where n varies from 0, 1, 2, 3 and so on. This is a condition for the dark band. So I will write here 2 mu t cos r minus lambda by 2 should be equal to 2n plus 1 lambda by 2 plus lambda by 2. This lambda by 2 will go there. You can take the condition as 2n minus 1 lambda by 2 also. When the n is starting from 1. When n is starting from 1, you can take n as 1, 2, 3 and so on. Okay. So when n is starting from 1, path difference is 2n minus 1 lambda by 2. So 2 mu t cos r should be equal to 2n minus 1 lambda by 2. Now I can say here that 2 mu t cos r should be equal to 2n minus 1 lambda by 2 plus lambda by 2. I will open the bracket. 2n lambda by 2 minus lambda by 2 plus lambda by 2. This get cancelled, 2 get cancelled, and you will get here 2 mu t cos r should be equal to n lambda for the dark. Means this is the condition for the dark band. So this is all about the interference in the thin films due to reflected light. We have studied about the path difference and condition for the point to be bright and condition for the point to be dark. Thank you.